Okay, the question for today is called coin flipping competition. So basically, we have two-person T and G are both flipping fair coins until respectively obtain their first heads. Find the probability that it takes T at least four times as many flips to obtain his first head as G. So the idea behind this is basically we have this T person who takes at least four times as many as G. So we can just kind of define, okay, so it'll just be using the law of total probability. We just condition it on the case that G is equal to 1, G is equal to 2, G is equal to 3, so on and so forth. And then for the case that G is equal to 1, we know that T has to be greater than or equal to 4, and then so on and so forth. T has to be equal to greater than or equal to 8 for G equal to 2, and so on and so forth. So we can just find what that probability is, right? When G is equal to 1, it means that, okay, let's just say that this was N. G was equal to N, and then T has to be greater than or equal to um, 4N, right? This is the condition. I'm so sorry. This is not looking very good. I'll just type in instead. So basically, in the case that P of G is equal to N times P of T is greater than or equal to 4N. This is basically the case we're writing, right? And we're just trying to find the sigma of this expression. So as n goes from 1 to infinity. So the further for P of G of E equals to n, what we have is the case that we just have a bunch of tails all the way to the final one is H. And in total, we have n characters. And then for the case that um, T is greater than or equal to 4N, it means that everything up to that point is T, and then we can do anything after that, so we don't care. So then this would just be N minus 4N minus 1 terms, right? Because we just have 4N minus 1 tails over here, and then it doesn't matter. And then this would just be a set form of N characters. So this is just what we have. So what this means is that, okay, our probability would just be 1/2 because it's just a fair coin. Um, and now we just have to the end, right? Because this is just for the first case. And then the second case would be we have 4N minus 1 that are set to be tails. So the probability of that would just be 4N minus 1. So this would just be the probability. And this is what I've written over here. And we're just summing it from n equals to 1 all the way to infinity. And then we just combine the terms to be this. Then we just okay, this is just an infinite geo series, right? This is the first term, and every time we just multiply it by 1/2 to the 5th power. So then we can just use the infinite geometric series sum to this, and then we find that this is our answer. So I think the major takeaway from this question is kind of just to use conditional probability and then the law of total probability added up together, and we would get what we need.